In number 11, we've got a triangle that has some missing information for us, and we're going to use a proportion to try to solve for those missing parts. We're going to have one ratio that's set equal to another ratio, and it's based on triangles that we know of. There's obviously one large triangle here, but because of this altitude, we also have a small triangle on this side, and then we also have kind of a medium-sized triangle over here. And we know some of those lengths. So depending, we're going to pick two of those triangles to put in our proportion, right? Depending on which lengths we know of which triangles, that's going to help us decide which triangles we want to use. We're going to have at least two sides that we know of from each triangle. So for example, if I look at the largest triangle, there's two sides that I know of. I know the short leg is 15, and I know the hypotenuse is going to be x. So that tells me I'm probably going to use that triangle because I know two things about it. The small triangle in here, again, I have a hypotenuse that I know of, and I have a short leg that I know of. But if you look at the last triangle, the medium triangle here, we really don't know much at all about this. We could say that this long leg is a total of x minus 9 over here, but I don't know the hypotenuse, I don't know the short leg, so I'm not going to use that medium triangle. I'm only going to use the small triangle and the large triangle. So once you know that, it's just a matter of then setting up your proportion and indicating where you're going to put that stuff. So let's say the small triangle is going to go in the numerator. It wouldn't have to, but you're just picking spots here and keeping them consistent. And then the large triangle values are going to go as our denominator. And the two things that we know about them, the two sides that we know, go here and here. Okay, so this one's going to be, we know something about the hypotenuse in both of those, and we know something about the short leg in both of those. Okay, so let's take a look at plugging values in. If I'm looking at my small triangle, that would be this guy right there. The hypotenuse of that small triangle is 15. If I look at that small triangle and find the short side is 9. And then I'm going to do the same thing with my larger triangle. If I look at the large triangle, which is the entire thing, the hypotenuse of that large triangle is x. That's the value I'm looking for. And if I look at the large triangle's short side, that would be 15. So now I've got information plugged into my proportion. All I have to do is cross multiply and divide to solve for my value of x that I'm missing. So I've got 15 times 15, which is 225. And I'm going to set that equal to the other cross product, which is 9 times x. Now I'm just going to divide both sides by 9 so that I can get x all by itself. And x must be equal to 25. And so that's the total length of that large triangle's hypotenuse. And if I wanted to, that would even allow me to solve for other portions, also other distances within this triangle too.